Good morning, students. So, in the last lecture, we saw the what are the different types of pollutions are there. Okay, what are the different pollutants are there in the particularly in thermal power plants. Now, the measurement of these pollutants, the levels of pollutants which are available in the exhaust of the thermal power plant, or we can say the water which is discharged from the thermal power plant or nuclear power plant, measuring those levels of pollutants are very important. And for that, we are going to use the different measurement instruments, okay, or the control instruments to measure the level of the pollutants or the different gases or different salts which are causes this particular pollution. So for that, the study of measurement and instrumentation in the power plant is very important because through this particular study we are going to control the amount or the we can say the control the levels of the pollutants in the water, in the air, etc. So instrumentation which are used in the power plant for numbers of reasons. Okay. So first of all, it is used to control the pollutant level, or sometimes it is useful to to monitor the condition of the water or the condition of the air which is used in the thermal power plant. So there are numbers of reasons for which we are using instruments. Sometimes it is also used for safety purpose. Sometimes it is also used for the monitoring purpose. Okay, so that's how we are using the different instrumentations or different instruments in the power plant. The main reason to use these instruments in the power plant is to operate the power plant more efficiently. That is the one of the major reasons. And then the instruments maybe those are used or furnishes the accurate information for the safe, continuous and proper plant operations for the safety purposes. The information which is given or the recorded by these instruments are useful to vary the different variables and we can achieve the best performance which is possible or the more efficient performance from the thermal power plant. Now, there may be used those particular instrumentation always used to take the internal condition of the equipment, also to indicate when or where the maintenance and the repair is needed. So, for the preventing maintenance or for the maintenance part also, we are using the different types of the instruments. The main function of the instrument is to, first of all, to it is used to operating guidance. Okay, to operations is that particular power plant is working smoothly or operating in efficient manner. For that, we are using the instrument or the instrumentation to calculate the performance of the particular power plant. Then the maintenance and repair guidance. For that also we are using we mostly use the this particular instrument. Then the economical supervision, then the cost of allocation, etc. So these are the different functions which are uh, for which we are using this instrument. Different types of the instruments have been used, and it will always going to control the different parameters. Okay, it will give the needed information, which is again used for the planning or to make the maintenance schedule, etc. Okay, so study of this instrumentation related to the power plant is very important. Now, if we saw in any particular modern power plant, the different types of the instruments are there. Generally, different pressure and temperature measurement of the steam and water. For those, we are using different instruments, particularly the thermometers or the thermocouples. Then the flow measurement apparatus are there. Carbon dioxide indicators are there from the exhaust gas. How much carbon dioxide is present in the exhaust gas or the different gases which are present inside the exhaust coming out from the boiler. So for that also we are using different analyzers. Then airflow recorder is there. Then draft gauge and vacuum gauge are there to indicate the pressure available in the drafts and in the different ducts. Then the fuel gas thermometer is there. Okay, to measure the temperature of the fuel. Then fuel meter is there to measure how much fuel has been consumed. Okay, so for that we are using the fuel meters. Then watt hour meter is there, or generally we can say this is the electricity meter. Okay, whatever the simple meter we are using in house, which is to measure how much electricity has been consumed. So that is known as a watt hour meter, and many other instruments are used. Okay, so we are going to see the important instruments which are very important regarding the to efficiently working of the power plant, and those instruments we are going to study in detail in the next slide. So first one, that is the measurement of the water purity. So the water is the main constitutes, or we can the working fluid of any type of thermal power plant or the hydraulic power plant, etc. Particularly in thermal power plant, we have to measure, or we have to uh, uh, find out the water purity. Okay, that is very important because it will going to affect uh, the corrosion problem. It will going to affect the maintenance problem, or it will going to affect the life of that particular power plant. Okay, because as we know, the pure water, it doesn't contain any type of salt or any type of contaminant in it. That pure water is ideal fluid for the thermal power plant. But in nature, if you saw, there will be no any there will be a very less pure water available. Okay, because whenever that water mixes with the or flowing through the river, some salt has been dissolved into it, some other contaminant will be present inside it. So the availability of the pure water is it's not possible in the nature. Okay, that much or whatever the amount of water we require for the thermal power plant, that much pure water is not available directly, not available in the market, or sorry, in the nature. So in that case, we have to carry out some processes on this water, and then we can use that water into the thermal power plant. Particularly, the main concern whenever we saw any particular water, that is the whatever the salt which are dissolved inside the water. As we saw in thermal power plant, there is phase change processes are there, where we convert the liquid water in the boiler. We are converting liquid water into the steam. So in that case, when there is dissolved salt will present inside the water, it will going to be, it doesn't going to be change its phase from its the solid to the vaporized form. Okay, in that case, it will going to be the uh, it will going to be precipitate on the inner side of the different condenser tubes or the boiler tubes, etc. And that will cause the corrosion problem. It will also reduces the heat transfer rate. So because of that, what will happen? The performance of that particular device will be decreases. The effectiveness of heat exchanger is going to be decreases. And that is the main concern we are going to see regarding the water purity. Uh, because of that, what we required, the maintenance we required, time to time maintenance we required. If the dissolved salt amount is more in the water, in that case, the scale formation is more, or that salt will precipitated on inside these tubes is the quantity of that salt is very high. So in that case, we required frequent maintenance, right? It will also going to affect the performance, and also going to affect the life of power plant or the life of that particular device. So in that case, measurement of the water purity is important. Means how much amount of salt has been dissolved into the uh, water, that we have to measure, and if that salt which is present inside the water is more than the prescribed limit, in that case we have to carry out different processes to reduce that level of the salt. Okay, so for that, this measurement of water purity or the measurement of how much salt has been present or the dissolved into the water is very important. Okay. Now for that, what we do, we are using electrical conductivity of water as a measurement, or the measurement property to determine the content of salt into the feed water. Okay. Now how this particularly we are going to use? We know the pure water is highly resistant to the electric current. Okay, whenever we take the pure water, pure H2O, that water doesn't pass if we try to pass the electric current through it, it doesn't pass. Okay, it is highly resistant to that particular electric current, or we can say it is the uh, it is its conductivity, electricity conductivity is zero. Okay, it doesn't pass any particular current through it. But if we add the different mineral salt or the acids or alkalis to the pure water, they will dissolve into the water, and it is dissociated into the positive and negative ions. It will create the ions. So when we pass the electric current, we try to pass the electric current through that particular water which is having dissolved salt. In that case, it will conduct that particular electricity. Okay, the electricity will conducted through that particular water, and that because of this particular dissolved salts or the acids or the alkalines, etc., present inside the water. Okay, so by using this property, that is electricity or conductivity, electrical conductivity of the water, we can calculate or measure the water purity, how much amount of salt has been dissolved into the water. Now, if that dissolved salt level is very high, in that case, we have to reduce it. Okay, reduce it below the prescribed limit. Okay, so these in turn, whenever the amount of dissolved salt is increases, it will increases the conductivity, and that increase in the conductivity is very proportional to the numbers of iron present. Now, therefore, this conductivity can be used to measure the amount of water or total dissolved solids inside the water. Okay, so these particular properties we are going to use. For that, we are using different instruments. The one of the instruments we are using, this is a simple type of instrument. You can see here. So this one is used to calculate or measure the amount of salt diluted or the dissolved into the water. So you can see there is one Viscount bridge. Okay, it will having four resistance. Okay, so R1 is there, R2, R3, R4 is there. Okay, total six resistors are there. Okay, and this third bridge has been connected to the amplifier, and it is again connected to the balancing motor, or you can say it is indirectly connected to the indicator. Okay, now what will happen in the beaker? We will take the water sample. Okay, and you can see here this particular circuit. You can see the resistance which is showing here, it is going to be play the important role. To in now to parallel to this particular resistance, we are using the RT, that is the another resistance. Then other resistance has been connected in the parallel and the series combination. And this is one simple Wheatstone bridge type of connection. Now, what will happen when we take the water into the beaker and we put this particular circuit into that particular water? Here, we are applying 110 volts of electricity or the voltage across this particular circuit. Now, when this electricity passes through this particular resistance, if that water is pure water, in that case, there will be no any passing, there will be no any current will pass through this particular circuit. Okay, here if we saw, the circuit will consist two open links, okay, or two open uh, one sec, two open contacts or the contacts are there. Okay, if there is a pure water, in that case there will be no any transfer of the electricity in between these particular contacts. Okay, so in that case, if this water is a pure water, the amount there will be no any transfer of electricity, and it doesn't giving or the this particular circuit doesn't give any deflection into this particular what we call as amplifier or any input to the amplifier. Okay, so in that case, the indicator will show zero reading. Okay, it will show zero reading. If the salt is present, or if salt is present in dissolved form into this water, what will happen? In that case, whenever we apply the voltage, the current will pass through in between these two contacts. Okay, those two contacts are not physically in contact. Okay, there will be a discontinuity, but around this particular contact, there is a water present. Water is present. Okay, so if There are dissolved, if there is any dissolved salt present inside the water, in that case, it will conduct the electricity from one contact to the another contact. Okay, and because of that, what will happen? Current will pass through this water, and it will pass through the this particular circuit will be closed, and because of that, whatever the pass current, it will going to give input to the amplifier. Okay, because the amount of current we pass through this particular circuit is very small. In that case, we have to amplify it. That current will be, or signal will be amplified, and it is given to the indicator. So in that case, indicator showing the respective reading. Okay, now whenever the amount of dissolved salt has been increases, the conductivity of water is going to be increases. So if you saw, the amount of total dissolved solid is directly proportional to the conductivity, electrical conductivity of the water. So as the amount of dissolved solid will increases, the conductivity of this particular water will increase, and because of that, higher amount of current will pass through in between these two particular contacts, and because of that, there will be a higher reading we will see into this particular indicator. Okay, so that's how we can measure the amount of salt or the dissolved solid present inside the water. If the level of this dissolved solid is more, okay, more than the prescribed limit, in that case, we have to reduce it. For that, we can carry out different methods. Okay, there are different methods to reduce the salts. We can use the chemical method. We can use any thermodynamic method to reduce the amount of total dissolved solids. Okay, so first of all, the main concern is to, first of all, we have to find out how much solid has been dissolved. Okay, how much dissolved solid that particular water will contain. Okay, so after measuring that, then we can carry out some processes to reduce that solid. If the amount of dissolved solid is less than the prescribed limit, in that case, we directly use that particular water for the different processes. Okay, so this is the simple instruments which is used to find out the amount of salt or the amount of dissolved matter into the water. That is the measurement of water purity. That is our first instrument that we saw. The second instrument, the another different, there are different types of meters or the instruments are there which are used to find out the dissolved solids. Similar to previous one, there is another type of instruments we are generally used to measure dissolved salt into the water. That is the ionic meter. Okay, and if we use that ionic meter, there are the units or the whatever the uh, reading that particular dynamic meter shows, that is given on this right hand side column, and it is for the different type of water. Okay, if we use the distilled water, or we can say the pure water, this distilled water means it is a pure water, there will be very low amount of salt is there. Okay, so distilled water, for distilled water, their dynamic meter will indicate the reading that is equivalent to 6. Okay, similarly, if you saw the condensate of the boiler fluid, it will contain the reading 0.925. Okay, the cooling water is not available. For tidal water, we can see the sea water. The reading you can see it is very high reading because the amount of dissolved salt is very high in the case of sea water. Then water tower, sea water, public water supply. For various type of water, the amount of dissolved water or the whatever the readings from the dynamic meter is shown here. Okay, now you can see concentrate on this particular part. The condensate coming out from the boiler field means what? It will indirectly give you the amount of dissolved salt or the salt which is acceptable in in thermal power plant. It must be in between 0.9 to 5 whenever we use the ionic meter. Okay, so this is regarding the water purity, measurement of the water purity. The next that we are going to measure, that is the dissolved oxygen recorder. Okay, now why this dissolved oxygen recorder is important, or why we require to find out the amount of oxygen which is dissolved into the particular water. Now, as we know, the oxygen is the main reason for the corrosion. It is the main responsible for the corrosion of the boiler tube or any metal, right? Because oxygen generally, what is meaning of corrosion? Corrosion means what? Where the oxygen will react with that particular material, okay, and after reaction, after reacting, the oxides of the material will generate it. If that oxygen will react with iron, it will generate the iron oxide. If it is reacted with the other material, it will create the oxides of that particular material. So these dissolved oxygen which is available inside the water or the feed water, it is the main responsible for the corrosion of different boiler tubes or the condenser tubes or the turbine, etc. Okay, so because of the corrosion, what will happen? The life of power plant will reduces, maintenance will increases, and that will going to affect on the profits from the power plant. Okay, so because of that, what are the amount of dissolved oxygen present inside the water? We have to calculate or we have to measure that dissolved oxygen. Now you will say the water itself having the oxygen, right? Because the formula, chemical formula of water is H2O, right? So uh, keep in mind that whenever there is oxygen present in the water or we generally if you say the water that is the H2O, it doesn't going to be react with material. Okay, so instead of this one, there is additional oxygen will present. Additional oxygen is present inside the water, which is in the dissolved form. Okay, so these oxygen only, this particular molecule of oxygen that is dangerous or that will take in part for the in the corrosion action or the corrosion reaction. Okay, and we have to reduce this dissolved oxygen. Now, how this oxygen will dissolve? There are many ways through which this oxygen will mix with the water. We can say the different plants which are below the water body, or sometimes the oxygen from the atmosphere directly dissolved with the water. So there are different ways or the methods are there through which the oxygen will dissolve into the water. But whenever we use that water into the thermal power plant, we have to reduce the amount of oxygen present, dissolved oxygen present inside that particular water. Now, to reduce the amount of oxygen, there are many methods are there. Particularly, we are using de-aeration method in water treatment plant. You can see that details on internet how the de-aeration process will carried out. Now, first of all, we have to measure the amount of oxygen present inside this particular water, and then we can decide whether we have to carry out a particular de-aeration process or not. Okay, so for that, the limit for dissolved oxygen into the water, it must be below the 0.1 cc per liter. The amount of oxygen which is present inside the water, it must be less than 0.1 cubic centimeter per liter. Okay, so that will be the limit. If the amount of oxygen less than this one, amount of dissolved oxygen is less than 0.1 cc, then we can directly use that water. If dissolved oxygen is more, in that case, we have to carry out different deaeration processes, and then we can use that particular treated water into the power plant. If we directly use that water, which is having high content of dissolved oxygen, it will going to corrode the tubes, it will going to corrode the different parts of the turbines or the different parts of the condenser also, and that will increases the maintenance, and also it will reduces the what we can say the life of the power plant. Okay, so the main causes, as we know, it is because of the leaky walls are also because of the defective fuels on the pump. That will also causes the dissolvement of the oxygen or addition of the oxygen. The equipment is always used to record the percentage of oxygen present inside the feed water, and that will indicate to help the alarm when the level exceeds above the allowable value. Okay, we are continuously monitoring the amount of dissolved oxygen into the water, and if that limit has been crossed, in that case, it will shows us or the indicates the alarm. In that case, we can take the uh, proper steps to reduce that amount of oxygen present inside the particular feed water. Okay. Now to measurement of the dissolved oxygen, we are using one type of measurement devices that is called as a dissolved oxygen recorder. You can see this is the dissolved water oxygen recorder. Okay. So now this one is the circuit that we are going to see. These are the recorders which is placed here. The amount means whatever the recording, continuous recording has been started. Recording of the oxygen is going on. So in that case, this readings has been recorded into the one recorder. The one battery is again given for the working of this particular instrument. This particular instrument is known as the dissolved oxygen recorder. Okay, this one is. This is the main instrument. Now, what will happen? First of all, whatever the feed water is there, feed water has been taken from the feed water wall or from that particular pipe. Okay. Now, this feed water pass first of all pass to the pressure reduction valve where we reduces its pressure. After that, we will reduces the temperature of that water below 20 degrees centigrade. Okay. So temperature we have to first of all reduce below 20 degrees centigrade. It will pass through this particular heat exchanger where we reduces its temperature. Now this reduced temperature water has been passed. It will be passed to the this B part. You can see where so it will pass through this particular B part where we maintain the flow of water. Okay, we are maintaining the constant flow of water which is enter into the C part. Now this one is is the main part of the oxygen measurement or measuring unit, the C part. Okay, it will contain that spiral type of instruments which will actually measure the oxygen. Now, for the measurement of oxygen, we are again using the thermal conductivity, electricity conductivity property, electrical conductivity property of the water. Okay, so if the oxygen, whenever there is variation is present, then it will indicated by by the particular indicator. Now, this particular part, which is oxygen measuring unit, it is called as a catharometer. Okay, it is called as a catharometer. Katharometer. Okay, so this actual oxygen will be measured into the catharometer. Now, and also this D part which will mixes the oxygen and the hydrogen gas. Now, how it will work? First of all, the water will came inside this B where we maintain the particular flow rate of the water. Now, here what will happen inside the B part, the hydrogen and the water. Okay, if there is water is there, then hydrogen gas will be entered and it will mixes with the oxygen, the excess oxygen present inside the water. Okay, because this water will contain O2. Okay, and it will mixes with the H2 hydrogen gas. For the this measurement we require the hydrogen gas. Now this hydrogen gas is mixes or they react with the oxygen gas. Okay, and after that this mixture will be passed through this particular oxygen measurement unit. Now this catharometer what is contained? It will contain four tubes which are in the spiral shape. Okay, there are four tubes or the four what we can the strips are there which are in the spiral shape. These four strips, there are total strips are there. Okay. Now what we do on the one side, the pure hydrogen gas will be introduced. Okay. For two strips, we are introducing pure hydrogen gas. Okay. And remaining two strip, we are introducing the mixture of hydrogen and oxygen. Okay, and also we are providing the current to these four different conductors. Okay, so when how it will indicate the amount of oxygen. Okay, now consider if there is no any oxygen will present, dissolved oxygen is present into the water. In that case, there will be no any oxygen will react with the hydrogen gas. Okay. And because of that, what will happen? Here also there is a hydrogen gas, and remaining two strips also contain hydrogen gas. Okay. So because of that, what will happen? Whenever we introduce the current, the conductivity will be the same. Okay, because on the both sides there will be only hydrogen gas will be presented. Okay, so there will be no any change in material present or the gas present, and because of that that conductivity will be the same on the both sides, and because of that there will be no any deflection in the particular needle. Okay, because on the both side the conductivity will be the same, and because of that flow of the current will be balanced. Okay. Now, if there is any oxygen present inside this particular water, in that case, what will happen? On other one side, there is always the pure hydrogen will be there. On the other side, other two will have the hydrogen plus oxygen atom. Okay, so this gas will contain hydrogen and oxygen atoms or the molecules. Now, here, what will happen in this case if we introduce the current? In that case, on one side there is the pure hydrogen, and on the other side there is a mixture of hydrogen and oxygen molecules. And because of that, what will happen? The conductivity property of pure hydrogen is different one, and the conductivity of the hydrogen and oxygen mixture is different one. So because of that, what will happen? The conductivity of these both sides will be vary. Okay, and because of that, what will happen? This particular needle will going to be deflect. Okay, because the circuit will non-balance, it is an unbalanced circuit, right? And because of that, what will happen? This needle will be going to be vary, or it will going showing some reading. Okay, so as amount of oxygen will increases, there is deflection is more. Okay, so as amount of oxygen, dissolved oxygen increases, the more oxygen will contain on one side, and more deflection you can see on this middle part. Okay, so that's how we can measure the dissolved oxygen. For that, we require the pure hydrogen gas. It will be provided to the calorimeter, and by using the calorimeter and conductivity property of the oxygen, we can calculate or we can measure the dissolved oxygen which is present inside the water. Okay, so the main important you have to study is that uh, why to find out the dissolved amount of dissolved oxygen, why it is necessary, how this instrument works, okay, and these particular readings will be recorded, continuously recorded into the O2 recorder, and for at any time you can took those particular records of the measurements of the reading, and you can decide whether we have to carry out the deaeration process on the feed water or not. Okay, so it is based upon the amount of dissolved oxygen. Okay, so this is the instrument which is used to measure the dissolved oxygen, and previously we saw the instrument which is used to measure the amount of dissolved salt. Okay, this is related to dissolved salt, and then that is later on is related to measurement of the dissolved oxygen. Okay, so two parts we have completed, that is the measurement of the dissolved salt and the measurement of the dissolved oxygen. The main we have to focus on that why it is necessary, why it is necessary to measure the dissolved salt, amount of dissolved salt, and why it is necessary to measure the dissolved oxygen. That is important. The reasons, if you know the reason, then you can find out, or then you can justify why we require this particular major instrument. Okay, so these are the measurement and control instruments. Those are used into the thermal power plant. Okay, so we will stop here. In the next lecture, we are going to see the another types of the instruments like measurement of the pH value, then the measurement of the different gases which are present in exhaust from the furnace or the boiler. Those instruments we are going to see in the next lecture. Okay, so we will stop here. If anybody have any doubt, you can ask now. Does anybody have any doubt? Okay, simply you should study the type of the what are the instruments which are used and how those work how the instrument is working. Okay, that is important. Okay, okay. So there will be no any doubt. So we will stop here. Uh, in the next lecture, we are going to see the remaining instruments. Okay, okay. So we will stop here. You can leave the meeting. Thank you.